Dear students, in last class I have explained the applications of dimensional formula. The first application, checking correctness of an equation. The second one, deriving the relation between different physical quantities, and I have given example for both the application. So, we are going to learn some more illustration for these two applications. The question is, check the correctness of the equation t is equal to 2 pi root of L by G. We have already used this equation in the derivation, but here the question is to check the correctness of the following equation, where t is given time period, L length, G acceleration due to gravity, and 2 pi is the constant. So, first let us write the equation, which is t is equal to 2 pi root of L by G. So, how do we check the correctness of the equation? We have to write the dimensional formula of every term, and then we have to verify that each term of the given equation should contain the same dimensional formula, and if the dimensional formula is same for all the terms, then the equation is dimensionally correct. Now, here we have square root. So, therefore, to make things easier, I am going to square the equation on either side. So, I will get t square 4 pi square L by G. So, remember I have just modified the equation by squaring it. Understood? Format is the same, okay, it is the same equation, but we have squared. Now, let us write the dimensional formula of every term. So, t is a time period. So, t, but there is a square. 4 pi square is a constant which has no dimensional formula, right. So, we do not write dimensional formula of a constant as there is no dimensional formula for it. L is the length. So, write capital L, divide that. G, what is G? Acceleration due to gravity. So, dimensional formula is same as that of the acceleration, which is L t minus 2. So, let us simplify. T square, this L will get cancelled, t to the power minus 2 in the denominator, take to the numerator, it becomes a t square. So, you can see both the sides of the equation have the same dimensional formula, that is why the given equation is dimensionally correct. So, this is how you have to write, you have to write that statement here. According to the principle of homogeneity of equation, all the terms have the same dimensional formula, that is why the given equation is dimensionally correct. Okay. So, let us see one more example, one more question. The question is velocity of sound in a gas. Velocity of sound, the symbol is given v. So, velocity of sound in a gas v depends on pressure. So, when we say depends, so we have tried always proportionality, depends on pressure P. We do not know what is the power of it, so I am going to write it as x. You have to always consider that power to be x. We do not know the power, dependent power, it can be square, square root, then inverse. Inverse means minus 1, minus 2, any power. So, which we have to calculate, that is our job. Our job is to derive the relation, correct, pressure P and density D. So, this is the second variable to the power y of the gas, derive the relation between these quantities. Okay. The next step is, whenever there is a proportionality, replace it by a constant k, P to the power x, D to the power y. Okay. So, this is one of the equation, and do write where k is a constant of proportionality. Okay. What is the next step? Writing the dimensional formula of each term. V, velocity, L t minus 1. So, I have told you before, you have to remember all these dimensional formula by heart, only then you will be able to derive all this relation. So, again let me revise or recall. First, area L square, volume L cube, density m L to the power minus 3, mass by volume. After that, so we have time period, which is a t, that is the fundamental. Then we have velocity Lt minus 1, momentum mLt minus 1, acceleration Lt minus 2, force mLt minus 2, correct, acceleration and force. Along with the force, we have other quantities like force, weight, tension, they all have the same dimensional formula. Then we have work energy mL square T minus 2, pressure and stress mL minus 1 T minus 2, and the last power, it is mL square T minus 3. So, this is how you should remember. Only then all these derivations you can derive, otherwise it is not possible to derive. So, that is why first learn those table which is given, it is there in the study material, or watch the video again. So, you will understand what are those dimension formula. Important topic, as I have told you this before, for all the competitive examination, this is the topic based on which the questions appear number of times. Okay, right. So, velocity constant k, no dimensional formula. P pressure, now I will write m L minus 1 T minus 2. What is the power? X. Density here d, m L to the power minus 3, and then y, right. So, next L T minus 1. Now, here we have combine, m to the power x, L to the power minus x, T to the power minus 2x, then m to the power y, L to the power minus 3y. One more step, L T minus 1. So, here we have m to the power x, m to the power y. So, make it m to the power x plus y, correct. The powers, they get added up. L to the power minus x, and then L to the power minus 3y. L to the power minus x minus 3y, and then T to the power minus 2x. Now, compare the power. Here we do not have m. So, when there is no m, what is the power of m? It is a 0, correct. So, this m, it is only Lt minus 1, correct. Velocity is independent of the mass. So, m to the power 0. So, when m to the power 0, if you compare, so x plus y must be equal to 0, correct. That is 1. And then you can even write this also. L, what is the power of L? 1 here. So, minus x minus 3y is equal to 1 power. For t, what is the power? Minus 1. So, minus 2x is equal to minus 1. Minus 2x is equal to minus 1. So, what is x? Minus will get cancelled, you will get half. So, we have found the value of x. So, once you get x, you can substitute in any one of the equation, okay, you can find the value of y. So, I will substitute in here, x plus y is 0. So, x is a half, which I will write half, plus y is equal to 0. Therefore, the value of y is, take this half to the other side, it becomes a minus half. So, there are only two unknowns, x and y only. So, and we have found them. So, write the equation. V is equal to constant k, P pressure to the power half, P to the power half, d to the power minus half, d to the power minus half. That is a V, k, P to the power half. Take this to the denominator, d to the power minus half, write it as a d to the power plus half. What do you mean by P to the power half? Isn't it square root? So, you have to write V is equal to k, for both power is same. So, square root of P by d. So, we do not know the value of k. So, that is why you leave it, because that is, we cannot find the value of k whenever we derive it, unless it is given. It is not given in the question, correct. So, you have to leave as it is. So, that is one of the disadvantage of the dimensional method. Limitation we call it. Disadvantage means the constant of proportionality cannot be measured with the help of the dimensional method or dimensional analysis. So, that is what I am going to explain next, the limitations, disadvantages of dimensional method, dimensional analysis. So, hope we have understood. Again, I have given an illustration for two more questions. One is checking the correctness of the equation, other is deriving the relation between the different physical quantities. Okay. So, now let us see what are the limitations, disadvantages of dimensional equations. The first disadvantage is the constant of proportionality cannot be determined. See, the actual equation is this: T is equal to 2 pi root of L by G. We have derived this, and when we derived, we got the equation like this: T is equal to K root of L by G. So, we can't find by this method of derivation, we cannot find the value of K. Then how to find K? By experiment we can find the constant of proportionality. So, that is the disadvantage, that is the limitation. So, what is the limitation? The constant of proportionality cannot be determined by the dimensional method. Okay. The limitation number 2, this method cannot be used for deriving equations involving trigonometric function. What do you mean by trigonometric function? Trigonometric function means sine, cosine, tangent, secant, cosecant, then cotangent. So, these are 6 trigonometric functions. Suppose if there is a equation which contains a trigonometric function, then we cannot derive such equation. I will give an example. So, later we are going to derive an equation called T is equal to 2u sin theta by G. So, this we are going to derive later in a topic called projectile motion. Okay. Now, you may ask why we can't derive equations involving trigonometric function. Sine 30 degree, what is the value of sine 30? It is half, it is a constant, it has no dimensional formula, correct? That is why if I try to derive this, then I will end up deriving T is equal to K into U by G. I will get only this much, K, that is because of this 2, K is nothing but 2 here. Then this sine theta has no dimensional formula, that is why we do not get that particular term while deriving. So, that means this equation is definitely, it is not a correct equation, because what is the actual equation? T is equal to 2u sin theta by G. Now, that is what the limitation. Given this method cannot be used in deriving equations involving trigonometric functions. Hope you have understood the example illustration for the limitation number 2. Next, we have limitation number 3. What is this limitation number 3? The limitation number 3 is this method cannot be used to derive equations where addition or subtraction is involved. So, you must have observed, see, all the equation that we derived, like K is equal to half mv square, this is what we have derived. T is equal to 2 pi root of L by G, this is what we have derived. Then we have derived today V is equal to root of P by D with a constant K. Okay. What we have derived is K mv square, K into root of L by G, then K into root of P by D. This is what we have derived. We have derived even F is equal to K into mv square by R. So, all these equations we have derived it, correct? But the equations like V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS. We have used this, but only to check the correctness of the equation. Remember, we haven't used it in the derivation because we cannot derive equations where addition or subtraction is involved. if there is an equation where there is addition or subtraction, okay, I can write even like this also, v square minus u square plus 2as. See, here there is addition, here there is a subtraction. So, these kind of equations cannot be derived using the method of dimensional formula. Okay.